Hello friends, welcome to this exercise on how to perform open and short circuit tests to determine the efficiency of a single phase transformer. At the end of this video, you will be able to conduct an open circuit test to determine iron and core loss, conduct a short circuit test to determine full load copper loss, determine the efficiency of the transformer at different loads.
Let us discuss losses in transformers. The efficiency of transformer is determined by formulas. Efficiency equal to output power divided by input power. The input power can be written as output power plus losses. It is very important to find the losses of the transformer to determine its efficiency. The efficiency of a transformer is high and in the range of 95 to 98%. This implies that the transformer losses are as low as 2% of the input power. While calculating the efficiency, it is generally much better to determine the transformer losses rather than measure the input and output power directly. In a transformer, the open circuit test yields the core losses and the short circuit test provides the copper losses. Thus, efficiency can be determined from these data with reasonable accuracy. There are two types of losses occurring in the transformer, such as iron or core loss or no load losses and copper or ohmic or load loss. The no load losses consist of two components, that is hysteresis and eddy current. Copper or load losses. This loss is mainly due to the ohmic resistance of the transformer windings. The load current through the resistances of the primary and secondary windings create I square R losses that heat up the copper wires and cause voltage drops. This loss is called copper losses or variable losses. The core loss in a transformer is constant loss for all load conditions. The copper loss varies proportionally to the square of the current. The open circuit test is performed to determine the no load losses or the core losses. A short circuit test is required to determine the transformer equivalent circuit parameters and copper losses. Let us arrange the equipment and materials required to do this exercise. Voltmeter, moving iron 100 volts. Voltmeter, moving iron 150 volts. Wattmeter. Ammeter, moving iron 5 amps. Ammeter, moving iron 15 amps. Frequency meter, single phase power factor meter, transformer, auto transformer, 3-pin sockets with switch control, incandescent lamp, tube light with choke and fittings. Conduct an open circuit test to determine iron or core loss. Identify the HT and LT terminals of the given transformer. Set the multimeter in resistance mode at the low range and measure the resistance of the primary and secondary windings. If the resistance value is high, then it is considered HT or high tension, and the low resistance value is considered LT or low tension. Here, since the given transformer is a step-up transformer, the primary is LT and the secondary is HT. Open circuit testing is always conducted on the LT side, that is, meters and the input supplies are connected to the LT side and HT side is kept open. In step-up transformers, input supply is given to the primary side or LT side and the secondary side or HT side is kept open. In the case of a step-down transformer, input power is given to the secondary side or LT side and the primary side or HT side is kept open. Connect the 3-pin socket with switch control to the AC 240 volt 50 Hz main power supply and plug the auto transformer into the socket. Connect the ordinary transformer primary, that is LT side, to the auto transformer terminals through a moving iron ammeter in series and a wattmeter as shown in the circuit diagram. Ensure the current coil and pressure coil are connected in series and parallel as in the circuit. Connect the moving iron voltmeter ranging from 0 to 150 volts parallel to the primary winding. Ensure the auto transformer knob is kept at 0. Now switch on the main power supply and auto transformer, then gradually increase the voltage up to the primary rated voltage, which can be confirmed with a voltmeter reading. Note down the voltmeter, ammeter and wattmeter readings in the tabulation. From the open circuit test, the ion loss or core loss is calculated. Conduct a short circuit test to determine the full load copper loss of a transformer. Caution: short circuit testing is done only on high tension side, that is, the input supply is connected to the HT side, and short circuit testing is done only the LT side. It may cause the windings to burn out if the short circuit is done on HT side. In step-up transformers, input supply and meters are connected at the secondary side HT, and short circuiting is done on the primary side LT. In step-down transformer input supply, the meters are connected to the primary side, that is HT, and short circuiting is done on the secondary side, that is LT. Connect the secondary side or HT side of the ordinary transformer to the auto transformer through an ammeter in series and a wattmeter as shown in the circuit diagram. Connect the moving iron voltmeter ranging from 0 to 300 volts parallel to the secondary winding, that is HT. Make a short circuit by connecting an ammeter ranging from 0 to 5 amps between primary windings using a thin insulated copper wire large enough to carry the maximum load current. Ensure the auto transformer knob is at 0. Now switch on the power supply and auto transformer and slowly increase the voltage up to the rated current, that is 5 amps of the transformer, by looking at the ammeter reading. Note the meter readings in the tabulation. From the short circuit test, the copper or variable loss is to be calculated. Determine efficiency of transformer or different loads. Connect the primary side of the ordinary transformer to the auto transformer through ammeter A1 in series and the power factor meter as shown in the circuit diagram. Ensure the current and voltage coils of the power factor meter are connected in series and parallel to the circuit. Connect the ammeter A2 and wattmeter between the secondary winding and load as shown. Connect the voltmeter V1 ranging from 0 to 150 volts parallel to the primary winding and voltmeter V2 ranging from 0 to 300 volts parallel to the secondary winding. Connect the variable load, that is resistive, which consists of incandescent lamps with individual control for each lamp at the secondary side, and ensure all lamps are in off condition. Ensure the auto transformer is kept at the 0 position. Close switch S1 and gradually increase the output of the auto transformer to reach the rated voltage. Close switch S2 and switch on the incandescent lamps one by one till ammeter A2 reads 25% of the load. Increase the incandescent lamp load to 50% of the full load, 75% of the full load and 100% of the full load, and record the readings in each case. Now remove the resistive lamp load and connect the variable tube light with individual control switches. Repeat the above steps by switching on the tube lights to get a power factor of about 0.9, 0.8 and 0.7 and record the readings in the table. Switch off supply after bringing the knob of the auto transformer to the minimum position. Calculate the efficiency using the given formula. Percentage efficiency is equal to output divided by input and multiplied by 100, or percentage efficiency is equal to output divided by output plus losses and multiplied by 100, which is equal to W divided by W plus W1 and multiplied by 100, where W1 is equal to iron loss plus copper loss.
I hope after watching this video, you will be able to conduct an open circuit test to determine iron and core loss. Conduct a short circuit test to determine full load copper loss. Determine the efficiency of the transformer at different loads. This concludes the exercise on how to perform an open and short circuit test to determine the efficiency of single phase transformer. Thank you. See you in the next exercise.